for the second workshop in this 8-part Spray Safe, Spray Well workshop series that will be taking place through the end of March. This work is possible thanks to support from a Northeast Extension Risk Management Education Award. This workshop is also being recorded, and a link to the recordings in both Spanish and English will be shared when they are available. If you have any questions during the presentations today, please go ahead and write them in the chat box, and we will read them aloud to the presenters during a question and answer period. We will also be launching a couple of polls during the presentations today. Participation in the polls is not necessary, but the information that we gather helps us to communicate to our funders the importance of this kind of work. In the first workshop on December 8th, we learned a little bit about how to decide when spraying might be necessary using integrated pest management strategies. Today, we are going to hear from 2 different speakers with some advice on how to effectively make those pesticide applications. First, we are very lucky to be joined by Maria Arce, who is a representative from TeeJet Mexico, and will be discussing spray nozzle selection and maintenance. So, Ana, thank you very much for joining us today.
Thanks, Ethan.
Hola, muy buenos días a todos. Mi nombre es Ana Maria Arce.
Hello, everyone. My name is Maria Arce. I am the responsible for the client service for Mexico and Central and Caribbean. I have more than 34 years in the nozzles of spraying. I'm grateful for the University of Cornell and Ethan, and I hope that this practice of nozzles is going to be useful to you all. So what are the functions of a spraying of chemicals? Is to prevent and control sickness, is prevent pests, is prevent weeds, is to also be able to spray nutrients, and it is also to be able to make sure that these applications are successful. We only want to spray in the necessary place, in the right place, and at the right time, and that it doesn't bring a risk to humans. And that's why it's so important to understand the functions that the nozzles have. And these functions are to determine the flow rate, to form the spray patterns, and to produce droplets of a given size. Now, what is the spraying and how is it obtained? The aspersion is to have a liquid of small droplets. And we understand that when we force that liquid at depression, goes through a little nozzle, the boquilla. For the spray patterns, they're going to create different patterns based on their design. The pattern is the form that the liquid is going to take when it comes out of the hole. There's different patterns for the different types of applications. Each spray pattern is going to give out droplets of different sizes. And the size of the droplet is a very important factor that we have to consider when we're going to select our spray nozzle. So we're going to see the different patterns, and we're going to see the hollow cone. This type of nozzle, like we see here, has very fine droplets, very fine, that are going to come out in spiral pattern and are going to help us have a whole cover in the leaf. And they are for direct spraying like insecticides.
Aquí vemos el video de una
Here we can see a video of a cone sprayer and how you can see all the droplets are concentrated in a ring, external ring. We are not going to have droplets in the center, like I'm saying. They come out in the form of a spiral, and they're fine and very fine. Now we have the full cone. Here you're going to see coarse droplets, and this is going to give more spray. This is utilized generally in the application of growth regulators. You can see here the video of a full cone. It's a circle, totally full. They're going to be more coarse compared with the ones of the cone spray nozzle. And they're going to come out like rain.
Tenemos también el patrón
And we're going to have the pattern of solid stream. This is going to be a stream of 0 degrees that is going to go directly to the objective without being in droplets. This we're going to use for sprays of fertilizers, liquids incorporated to the soil. And we're going to have little openings of 1, 3, and 7 streams. And last, we are going to see target edge flat fan spray. It's going to be 2 forms, usados and spray, which is kind of fan and then spray. So here is the spray fan, total applications, or for applications that are going to be a little bit wider, like a tree. There's going to be more liquid in the center than what is in the extremities. So when we use this type of nozzles, we want to overlap so we can get a uniform cover at the whole entire length of the sprayer.
Aquí estamos viendo un video.
Here we're seeing a video of a nozzle that is the nozzle that we're spraying with, that you can see it with the laser at the bottom, and we can see that there is a line, and we can see how really there is more at the center and how there's less and less towards the edges and the extremities. Here we have a different pattern that is a dual spin pattern that is going to have a double sprayer. It has this little nozzle that is going to have two little holes of spraying. So it's going to give two patterns of spraying that we're going to see, one towards the forward, the front, and one to the back. And there's an angle of 60 degrees between both of them. The size of this droplets of this nozzle is going to be smaller if we compare it with a nozzle of the same use. So now we are dividing the use of the spraying between two nozzles. These are great for a great covering of the leaf, and also if you want to use penetration of the foliage. Here we can see the video of TeeJet of double fanning. We are also using a laser, so you can see that there's two patterns of spraying. There's an angle of 60 degrees between them, and just like that, we can see how there's more liquid at the center and there's less liquid towards the extremities. And the other type is the even flat fan. This pattern of a spray is going to have a distribution that is uniform at the whole length of the pattern. Here you can see the same amount of liquid in the center like in the extremities and the edges. It's going to be medium droplets. And these little droplets that have these, they are ready for applications in band and when we make applications with the backpack sprayers.
Ahorita es el de la distribución y el traslape. Les vamos a presentar ahorita un video de una mesa de distribución.
So we're going to present now a video of AXR of 116 degrees. They're going to be put at 20 inches of height, 20 inches of separation, and they're going to be going at 40 of pressure. And for this, we need a consistent distribution of liquid throughout the boom so that we can achieve a better coverage with this boom. What we're showing here in this video is that it has a boom that can be adjusted, its height, so that it can simulate what it's like on the field. And this collected liquid can be measured, like we can see here in the inferior part of the table. And that way you can calculate the distribution. This is known as CV. This is expressed in a percentage. So 0% is a perfect distribution, and a 7% distribution is actually very good. And this is actually below 7%. This, as you can see here, it's 3.6%. So this means it's extremely consistent application when used. So what we're showing here is what is the distribution of this fan. You know, what I was saying here is that these sprayers and these nozzles are going to give more to the center than to the side. So when we use this type of nozzle, we have to translate it to the 30%. What does that mean? We have to count on a dispersion pattern of a third of the space. When we want to have a correct type of overlay and overlap, we have to work with the right amount of pressure. We have to have the right amount of separation between nozzles. You also have to have attention to what is the right height of spraying. We have to really measure the height from the tip of the nozzle to the top of the crop that we are spraying. A really important point also is that in order for this to be correct, is that the patterns of spraying cannot come into contact with each other. So what we have to do is have a deviation of 10 to 15 degrees to prevent that these patterns overlap. If we use the QuickJet system, that means the one that we use with our hand, that we don't need a tool, this deviation of 15 degrees is already going to happen automatically. The system has it included. However, if we're using a traditional system of screwing, that we have to do it manually so that the patterns do not touch. Here, we're going to actually show what a correct overlap looks like. Like you can see, there is a good separation between nozzles. The height of the nozzles is adequate, and the distribution of this liquid is even. But if we have an insufficient coverage, it looks like this. If you see there's too much distance between nozzles, it could also be that the boom is too low. So what happens? Valleys are formed. What does this mean? We are not applying enough product in certain areas. Therefore, our coverage will not be uniform if we compare it with the image above. In this other image, we see what excessive coverage looks like. Notice that the distance between nozzles is too little. It's incorrect. They are too close together. The same thing would happen if the boom is too high from what is ideal. So we see peaks. As you can see, the distribution is also not uniform. So we have to be careful with the distance between nozzles, and we have to be careful about the height of the boom. So now we will present another video. This is what happens if we do not have the height that is appropriate. So we're showing 116 degrees again. Now this is 20 inches of separation of the nozzles, but we lowered the boom. Instead of a 20 inches, we did it at 12 inches. So doing it too low, it's gonna make it have a bad distribution. So our coverage will not be optimal if we do it this way. The quality of the distribution is 2.5 times worse than if the boom is at the optimal height of 20 inches above the prop. We see that the distribution of liquid is not optimal. If we maintain the appropriate height, what we will see is a better distribution of what we're spraying, and it's going to mean better coverage on the crop, and that will mean better control of the pests. You see here, the distribution here is not optimal. Here, the coefficient of variation is 9% compared to the 3.6% if we had actually used the recommended height on the boom. So as you see, it's really important to maintain the correct height of the boom. Also maintain the correct distance between nozzles so that we can have optimal coverage. Now, we're going to see how we should choose our nozzles depending on the application we want. In our catalog, which you can find in our website, which is www.teejet.com, you'll find in the first pages are guides to selecting nozzles, depending on what is the type of application you want to do. Here, we show you the guide for total application or air application. So as you can see in the top part, we see the 3 types of products: herbicides, fungicides, and insecticides. Below that, what you see is the type of action of the products. So you can see if they are systemic or by contact. So let's focus here on herbicides, contact herbicides. So what we see is that the excellent nozzles for application is like the Turbo TeeJet, also the nozzles that are XR, also the XRC, and the twin jets. In the case of fungicides, also of contact, it recommends the TeeJets, the nozzles that are AI 3070, the nozzles that are XR and XRC, as well as the TeeJet. So this is a quick guide for reference so that you can see what nozzle to select for the type of product and the mode of action that you want. TeeJet also has a free app. It's called Spray Select, and this can be used on iPhone or Android. You can choose your language, you can choose the units, you can do the meter or not. And this application is gonna take us by the hand, asking us questions. Like it's gonna ask what type of application, if it's with a boom application or by flying or what kind. And once you choose the type of application you're using, it's asking if you're doing an insecticide or a fungicide. So it's also going to ask the mode of action. Is it going to be systemic or is it going to be by contact? Other questions. What is the separation between your nozzles? What is the velocity? What is the pressure that you're going to be working with? What is the density of the liquid? And when we put in all those inputs of values, the application is going to tell us what nozzles they suggest for that type of application, including the type of droplet that we're going to obtain when we use it. So it's a super useful application. I really recommend it. Now we're going to talk about the life shelf and the maintenance that we have to do on our nozzles so that we prevent its deterioration. It's not enough to look at it. Sometimes the deterioration isn't seen to the eye. Here we're seeing two different points. First they look the same, but if we see below, we see that the distribution of liquid is actually really different. The fact that our tips are getting worse, it means that we have to make sure that they're doing the optimal job. So when they start to wear out, the hole starts to get bigger. What happens? That the pattern of distribution gets deformed, but sometimes you can't see it with your naked eye. So when is it that I should replace the nozzles? Well, when we check that the nozzle is giving 10% more flow compared to a new nozzle of the same type. A best practice is to always have a new tip so that you can compare the flow with the tips that we're already using and installed, or have the catalog on hand so that we can really see the true flow of the new tips. When we have a nozzle that has several tips, if we could prove that several of the tips are worn out, we recommend changing all of the tips, because if you used all of them at once every time, then the wearing out will be the same in all of them. Remember that when you replace your tips, actually the cost is less than waiting to replace your tips and doing a bad job. So we're going to see in this video the comparison between a new and a worn out tip. So here we have a flat tip, and this nozzle is working 30% worse. Which one's worse? We see here the right side is worn out. It's losing. We can see here that the distribution is not uniform at all. How can we show that a tip is worn out? Well, we should use a recipient, a gauge, and put it below the tip, collect liquid for a minute, and we compare what we got compared with a new tip of the same kind. Or we compare what we got with the catalog. It's really important that we use the right pressure. And you always do this test with water, never with a pesticide. Why do tips get worn out? Well, this could happen for several reasons. For example, the material in which the tip is made. We know that some materials are more resistant than others. Another reason can be the type of product we're using. Some products are super corrosive and abrasive. Also, the pressure we're working with, the bigger the pressure, the bigger the wearing out that's going to happen. And the material is kind of the easiest to control of all of these so that we can elongate the life of the tips. And in general, those materials that have harder, that are harder will have a longer shelf life. So in this left side, we can see the hole of a new tip. In the middle, we see the hole that is kind of worn out by use. And on the right side, a hole that was cleaned incorrectly. So as you can see, the damage done by cleaning incorrectly is worse than the damage done to a tip just by using it. So we're going to talk a little bit about how to clean these nozzles. We're going to see this video of using a tip that is clogged or obstructed. This is at 20 inches of separation and 20 inches of height. And we see a tip here that is clogged. It's partially obstructed. What it creates is a hole, a gap in the distribution. This hole gap, it's gonna mean a worse application in the crop, which might mean poor control of the pests in this area. The quality of distribution will improve 5 times when we remove this tip and we clean it appropriately. In TeeJet, we have monitors of flow, and they detect in each tip when a small reduction is occurring in one of the tips due to obstruction. Then that gets communicated to the operator. The fact that we can detect these types of problems can prevent the necessity to repeat application, and it can improve the yield of the crops. Here we can see the sub-application in this area due to a clogged tip. In this case, we see that this caused a 17.4% compared to the 3.6% that we get when we use new tips.
Programa de mantenimiento, debemos de limpiar las boquillas y sus
So
orificios.
for the maintenance program, we have to clean materials that are softer than the material that we're going to work with, because we don't want to ruin the hole, and that we don't want to end up with patterns that are distorted and that with major flows. So to be able to clean the holes, we suggest using very soft brush bristles. Never use wires, nails, sticks, or any other metal object that is going to be able to damage the hole. If you have spaces that are very difficult, you can submerge them into chemical substances like soap, vinegar, and this can help soften and dissolve the substances that are covering that hole. The lifespan is going to depend on the maintenance that you give it. And if you want is to have the right applications, it's very important that we use the nozzles that are working at the optimal stage. So like you saw, the nozzles of spraying are a very small component, are very important, because through them, it's going to be the whole chemical product that is going to get to the crop in the right amount that we want. If we don't find the right nozzle, we are not going to be able to write flow, the angle, the pattern, or the size of droplet that we're going to need. And our applications are not going to be correct. I'm so grateful for your attention. I hope that the information that I shared with you all was useful. And I repeat, in TeeJet Technologies, we are here at your service. And I'm thankful for Ethan for his invitation.
Ana, thank you so much for that great presentation, full of information, especially I think for organic growers who often are completely new to the conversation around nozzle selection. There aren't any questions in the chat yet, but if you do have a question for Ana right now, you can go ahead and enter it there. We might have time for 1 or 2 quickly. And while you're thinking about those questions, I am going to launch the first poll. So if you are able to respond just about what you were able to learn from Anna's presentation, like I said, we will use this information to demonstrate to our funder the importance of this information. I also just want to remind at least growers who are in eastern part of New York or close to eastern New York, we do have support to work with you in the spring to complete some calibrations of your spray equipment like Anna demonstrated, so we can see if you have more nozzles, what your distribution looks like, and also maybe try out the impact of some different nozzle types using some water sensitive cards that I think Jason will be talking about as well in his presentation. We'll move right on, except there is, Ricardo has a question, and Ricardo says, sorry, let me pull this up here. What would be the method of calibrating droplet size and output volume in nozzles for manual applications? For example, using an application with backpack sprayers. Anna, do you want to address that really quickly? And I think Jason will probably cover this a bit more as well.
Sí, para aplicaciones de mochila.
Yes, to be able to spray with the backpack, the calibration would be practically the same. The gauge will be the same. The only difference is when we use backpack sprayers, it is different to gauge. We have to be careful with the velocity, the speed, because obviously the speed at the pace in which people are walking is different. The height, people can be higher or can lower their arm. And also the pressure that we often have with the backpacks doesn't have the valves that we're going to keep a constant pressure. So this can be a theme, but the gauge would be the same. We would measure exactly the same. One boom. But the theme of velocity, speed, and the height and the pressure, you have to be careful with the backpack sprayers.
Thank you, and thank you for the great question, Ricardo. That is certainly something that we are able to help support growers with in the spring, is calibrating those boom sprayers, which is a little bit more difficult, as Anna mentioned. Gabi also shared a question, and Anna, maybe you could quickly review this. ¿Cuáles son las causas más comunes de obstrucción?
Which are the most common causes? And how often in the obstruction of the nozzles, how often do we have to clean them?
Usan filtros.
The main problem is that we don't have filters, or that you use filters that don't have the filters, the right filters. So I recommend that on top of using filters in the lines, also use filters in the nozzles, and that you're constantly cleaning them. And that the nozzles are also cleaning often, because the problem is not always that the hole is big enough, is that the nozzle gets clogged inside. So using the filter with the right mesh can avoid a lot of problems of obstruction for y'all.
Thank you. And I did just relaunch the poll. So if folks could go ahead and respond. And Jason, thank you for keeping your hands off the mouse. There is one last question. And after this, I think we will move on to Jason's presentation in the interest of time. But if other folks think of additional questions, please continue to write those in the chat and we'll come back to them at the end. But Tony has a question, Anna, which is, do you know of any supply chain issues right now about inventory or availability or shipping of nozzles that might make it hard for folks to get the type of nozzles they're looking for?
Sí, ahorita debido a la pandemia ha habido problemas de distribución.
Because of the pandemic, we have been having distribution problems. There is a lot of time between shipment. There is a lot of components of spraying, the valves. It is a little bit of a problem, like many other elements. There is a little bit of problems because there's not a lot of people or transportation, boats, and being able to send things. It is a little bit of a problem to be able to find nozzles. Yeah, and that is a theme we have to be aware of. In the webpage of TeeJet.com, you can see where you can buy, and you can find different distributors and where you can find distribution. But yeah, the times of delivery are a little bit long. And I know that there is a lot of problems in all different aspects because of the pandemic.
And like I said, if you continue to think of questions, please put those in the chat. But for now, Anna, if you could go ahead and stop sharing your screen.
Claro que sí.
Thank you. We're going to turn it over to Jason Deveau, who is the Application Technology Specialist with the Ontario Ministry of Agriculture, Food and Rural Affairs. And Jason is going to discuss some considerations for achieving good spray coverage and for selecting spray equipment on small organic farms. So Jason, thanks so much for joining us today.
Thank you for having me. And hello to everybody from my cold Canadian basement. My name is Jason Deveau, and I've been a sprayer specialist with my provincial government for the last 14 years. And I spray or help growers spray a lot of crops, everything from broad acre corn all the way to hops and some fun crops like that. And it surprises people that I like to talk to organic applicators because I help spray chemistry. And what does an organic applicator want with chemistry? Unfortunately, some people think this is the attitude of organic operators, that they're going to respond by saying, I use organic products. I don't need a talk on spraying. Well, let's talk about the sprayers themselves for a second. This is a sprayer. This sprayer is actually spraying tree nut in the United States. Maybe you didn't think that this was a sprayer. This is a sprayer. We use this for a lot of broad acre applications. This is kind of what a lot of people think of when they talk about a sprayer. Unfortunately, this is also a sprayer. This was up for auction here not too long ago, and I love pictures like this. But for a long time, this was how people sprayed. And really, even this is a sprayer. So with all these different ways to spray, there are different rules. Ultimately, it really doesn't matter what equipment you use or even the product you are spraying. My goal and my role is to help any application be efficient, effective, and safe, whether you're an organic operator or a conventional one. So, in fact, spray coverage might even be more important for an organic operator. A lot of organic operators use biorational products. Most are contact products, which makes coverage very important. Most have low residual, which means they don't last as long as some conventional products. And most are suppressants. That means you don't get the same control of a weed, a disease, or a pest as you would with a conventional product. All of this makes it very important to know how to spray well. Let's start with a little bit about droplet size, rate, and pressure. And we heard some of this already. Pressure, droplet size, the amount of liquid that comes out of a nozzle, and the coverage you get are all related. On the left-hand side of your screen, you can see a 90-degree flat fan, which we just learned about. If it's operated at 1 bar or 15 pounds per square inch, you can expect to get about ½ a liter per minute to come out of that nozzle. And it will tend to make larger and fewer droplets. And you can see that in the bottom on water-sensitive paper. This is a great tool for anybody spraying. It shows you right away what kind of coverage you're getting or what kind of coverage you're not getting. To the right of the screen is the same nozzle. All we did was raise the pressure. Now you can see we go up about 25% of the flow. We're getting 0.76 liters per minute. We can see that the fan angle has gotten wider. It went from 90 degrees to 110. We can see that it is producing more droplets and that they're smaller. And we can see what that looks like from the plant's point of view using the water-sensitive paper. So the lesson here, it is not just the nozzle you choose, but how you operate it that can make a difference. When you're trying to decide what kind of nozzle to use, as we heard earlier, nozzle manufacturers provide tables to help you pick what you're looking for. Let's say we have a red nozzle. You don't know what it is, you don't know what it does, but you would like to find out what happens when you change the pressure. You go to your manufacturer's catalog and you look for the red column. You can see that depending on the pressure, you're going to get a different rate. Find the pressure that you use, in this case 9 bar, and you see where the two intersect, we end up with 1.83 liters per minute. That means if you use this nozzle at this pressure, this is how much flow you can expect. Let's go the other way around. Let's say you don't have a nozzle, but you want one, and you know what flow you are looking for. Perhaps it's something like 0.92 liters per minute. You look at the chart and you see there are a couple different ways to get 0.92 liters per minute. Which one is best? In this case, we like to operate nozzles in the middle of their pressure range. That gives us some flexibility if we want to make a change. If you were to choose the brown nozzle, which is at the bottom of its range, you would have to go to 20 bar. Maybe your sprayer can't do that, and maybe it changes the spray quality too much. So we would prefer to use the yellow nozzle at 8 bar. I mentioned pressure, and I mentioned how that affects your spray quality and your coverage, but what you're spraying also matters. The density of the solution you're trying to spray can change the size of the droplets, the spray angle, and how much comes out. A rule of thumb, the thinner the solution, like water, the more will come out at low pressure. But the thicker the solution, the more viscous, the less will come out. So if you are spraying, say, an oil, which a lot of organic sprayers use, it could reduce your output by up to 30%, no matter what the nozzle manufacturer's table says. And you need to know this, and you need to check this. Keeping your pressure consistent is very important. We heard earlier that if you change how fast you walk, it's going to change your rate. The same with pressure. And a lot of small operations tend to use the sprayer on your left. You can see that this is a hand pump system. Every time you pump, you increase the pressure. Then it slowly runs out of pressure and you pump again. That does not give consistent results. If you do own one of these sprayers and you intend to keep using it, install a pressure gauge at the handle. You can see I've circled it here. See for yourself as you pump, as your pressure goes up and down. The better choice is to use consistent pressure. This might be a smaller sprayer with a pump, or it could be something operated by carbon dioxide, such as in this case. You set your pressure on a regulator and pressure is no longer a concern. Now we'll move on to target location and droplet size. Once you spray a droplet into the air, there are only 3 places it can go. Hopefully, it lands on your target crop. Or if you're not aiming for the ground, it could end up there too. Or, the worst of all of them, it could stay suspended in the air, and very fine or small droplets are capable of doing this. To get the best results from spraying, you should know what your target is and where your target is before you start. The location of the pest and how your chemistry works are going to tell you how to spray. For example, if your pest is under a leaf, like disease or maybe a sucking insect, if you spray straight down using large droplets, they're going to land on the top of the leaf They are not going to change direction and come up from the bottom. Only finer droplets or directed sprays can do that. If your pest is on fruit, that target is harder to spray than, say, a leaf. We call that a hard to wet target, and smaller droplets are better there. Maybe it's a weed. It's on the ground, no problem. It's under a plant on the ground, it's harder to get to. Or perhaps it's a soil-borne pest, and you're more interested in a drench application than spraying. All of these things will change how you should spray. Now, I mentioned droplet size. It matters. Larger droplets behave differently from smaller droplets. And depending on which nozzle you use and which pressure you use, you can take advantage of this. The coarser droplets, they survive longer. They're really big, so they don't evaporate as quickly as smaller droplets. Also, since they're so big, wind doesn't tend to deflect them. You aim them and they go in that direction until they fall straight down. They also stay wet on the target longer, and this can matter. Some products need to be taken up by a plant, and a big wet droplet has more opportunity for your active ingredient to get inside the leaf. If you look at this table, you'll see we have 4 different droplet sizes. 20 microns, that's what the UM means, all the way up to 150. Now, I admit these are very, very small droplets. You may never go this small, and I hope you don't, but it shows the difference in how they evaporate. That 20 micron droplet, and you can think of that as fog, will disappear under most conditions in less than half a second. So it has to get to its target before that happens. The 150 micron droplet gives you about 16 seconds. That gives it more time to get where it's going. Obviously, what you're spraying and how far away you are and the weather affect this table, but it does show the relative difference. I told you to consider what you're trying to spray. On the left is a mullein bug. This is a big pest in apples. It's about 2.5 centimeters long, or 2,500 microns. You can see that if you sprayed 250 liters per hectare, or 25 gallons per acre, you would get droplets that would deposit maybe 6 per square millimeter. All this means is, possibly, you can't miss it. Compared to that pest, this will be like landmines all around it. On the right is a much smaller target, a pathogen or a fungal spore. Again, this is for apple. That pathogen is only 15 microns long. So if you were to spray with the droplets on the left, you might miss it. But if you use finer droplets, there are more of them and you get a higher droplet density. That means there's more per square area. In this case, just dropping your droplet size could give you 400 droplets per square millimeter, where previously it was only 6. So using the right spray quality to match the pest that you're after is important. Finer droplets are tricky. They blow off course. Unless you're using something to encourage them to go in the right direction, like air assist, they're very hard to control. But if you can use them, they are capable of going places that coarser, bigger droplets can't. A coarse droplet lands on the first thing it hits. Think of it as line of sight. If the nozzle can see the target, you can hit it. But if your target is deep in a canopy, only a finer droplet can weave its way around to go deeper into the canopy and maybe hit your target. It's also capable of sticking to hard to wet targets like small weeds or fruit or stems. It can even go up and under a canopy to hit the bottom sides of leaves if you do it right. Some people may think, okay, I like the fine droplets. It sounds like there's more of them and you have a better chance of hitting your target. but they don't go where you want them to go. So I'll just increase the pressure. That should make them go faster and further. Well, that's not true. Imagine you are throwing a golf ball and you throw it gently. It'll go a short distance. But then if you increase the pressure, say, throw it a lot harder, it will go further. Coarse droplets respond differently to pressure than fine droplets. If, let's say, we are throwing a feather, our fine droplet, and we throw it gently, that's low pressure, it won't go very far. In fact, the wind may blow it back behind you. If you increase the pressure and throw it a lot harder, almost no difference. It won't help a fine droplet go any further or any faster. Not really, anyway. In fact, the higher the pressure on a nozzle, the finer the droplet gets. So you're kind of shooting yourself in the foot. How do you know if you actually hit your target? You have to have some way to confirm your coverage. I mentioned before, I like water-sensitive paper. I happen to be showing TeeJet here, which should make my colleague very happy, but you can also buy Spot On from the United States or WS paper from Brazil. I've tested all of them and they work great. They're very easy to use. You buy a package. They tend to have 50 papers in them. This is the smallest size, which I like. If you touch the yellow surface with your finger, it's going to turn blue. It responds to oily fingers the same way it responds to spray. So you have to handle them carefully. What I like to do is kind of close-up magic. I take a few out of the pack, I turn one upside down, and I pinch them all using that paper. What that does is give you two sensitive sides. Then, using a safety pin or a paper clip, anything you like, you can attach it to your plant facing any direction you like. Put it deep inside to see where your spray is going. Put it downwind to see if you're drifting. Put it on fruit to see if you're getting your coverage. If you don't like what you see, you have to make a change. I mentioned that it's capable of being used a lot of different ways. This was an experiment we did in chrysanthemum, flower spraying. Our grower was spraying with no air assist. They were just using a handheld boom. We compared that to an air assist boom, like a backpack mist blower. And we collected leaves from all through the plant. We also used water-sensitive paper. And we could see very clearly, most of the spray ended up on the outside, the easy to hit target, and less as you went inside the canopy. In this case, the air assist did a much better job because it blew the spray into the canopy and opened that canopy up. When you use the paper, try to only make one change at a time. If you put paper in a canopy and spray, and then collect that paper, and then make 4 changes to your sprayer, maybe a different nozzle, a different pressure, a different driving speed, or walking speed, and you put another paper in, which of those factors made the change? You don't know. So only make one change at a time and learn from what you see. What sprayer should you use for an organic operation? Well, it depends. All sprayers have the same basic parts, and I've drawn one here for you. All of them tend to have some kind of pump. All of them have a tank that holds your spray mix. All of them should have a filter to get rid of chunks and bits you don't want that might plug your nozzle. And all of them have a form of atomizing, a way to turn that liquid into little drops. Maybe it's a boom with lots of nozzles. Maybe it's just one. The better sprayers have a few more features. A bypass line allows spray you don't need to go back into the tank. It may help agitate or stir up what's in the tank. Quite often in organic spraying, a lot of our products will reduce into layers or fall out of suspension. If that happens, you won't get consistent spray. A pressure gauge will tell you what pressure you're operating at, and tip strainers or filters will help collect those chunks that maybe got through the main filter all the way to the nozzle. I still haven't told you which sprayer is best, have I? Again, it depends. What kind of design would best fit your operation? Somebody growing 1 acre probably doesn't want a self-propelled sprayer that is capable of driving several acres. Why pay for it if you don't need the features? How long will it take for your sprayer to get the job done? Do you want to spray all day, or can you get it done quickly? Can you even afford a high quality sprayer? Maybe you can get away with a used sprayer or something that isn't quite so complicated. What happens when it breaks down? And I don't mean if, I mean when. Is somebody nearby that can help get you back on your feet, supply you with new parts, tell you how to use it correctly? How long do you want it to last? Maybe your operation is growing and a sprayer that works for you now won't work for you down the road. And how difficult is it? Some people like me, we call ourselves nozzle heads. We like sprayers. We like to spray. Not everybody does. If it's hard to explain, use, or operate, maybe it's not the sprayer for you. One thing I find is hard for people to understand is that a big sprayer is not necessarily a better sprayer. Small and accurate and a good fit for your crop is the best way to go. This sprayer is towed behind a mower. It's for high bush blueberry. And before this grower got this tiny sprayer, he was having a hard time with a lot of pests, like spotted wing Drosophila, big pest in horticulture. But there are others. This is PBM's Little Squirt. This works for crops like blueberry or grape. Again, it's towed, so you don't need a tractor. It's self-powered by battery or gas, so you don't need a power takeoff. It's quite smart, well-priced, and convenient. Or maybe you can get a skid-mounted sprayer. Now, all of these use air because I like air, so these are the ones I like to show. In fact, for really small operations, or if you have to reach high into a tree or a bush, I am a big fan of backpack mist blowers, like this one here. But they are not all created equal. I found that out when I bought mine and instantly hated it. But you live and learn. If you're going to pursue one of these sprayers, get a hip belt. It holds it firmly on your back and makes it more comfortable. Also, get a pump kit. I don't know why these come out as options. They should be must-haves. The pump kit makes sure that the spray comes out at a consistent rate. You can see here how we use it in peach. This is just water. That's why he's not wearing any safety gear. Here it is in a raspberry. Very easy to use, small droplets which are propelled by air. And I mentioned earlier, we were playing with these in flower crops. On the left is a modified mist blower like the one you just saw. And these papers were taken from deep, deep in a canopy. Very nice coverage, no misses, no drips. On the right, this was the conventional system, no air, just spray. In fact, on the right, they sprayed 3 times the water volume that I used on the left. If you can control where small droplets go, they're very good. We talked a little bit about calibration in the last talk, and it is harder to calibrate a handheld or backpack system. This is me in my safety outfit, and with this sprayer, I didn't buy a pump kit. That means when the nozzle is held up in the air, the flow gets slower. It's gravity fed. When it's held down, the flow goes higher. So when you calibrate these sprayers, you have to walk and move the way you would if you were actually spraying. This takes the average. I mentioned agitation, stirring up your tank. For organic products and lots of products, bad things can happen in that tank. Products can separate, like oil and water, or they can also emulsify, like turn into mayonnaise. If you have too much agitation, you get mayonnaise. If you have too little, things can fall or separate. Unfortunately, a lot of the backpack systems don't have agitation. So dance. There is no healthier person than someone who sprays with a backpack sprayer. It's like doing yoga the entire day. Just wiggle to stir it all up. Somebody has video of me doing this, but I won't say who it is. That's a lot really quickly. So I want to leave you with a few resources that you might find helpful. A few colleagues and I wrote a book last year. Actually, this is the second edition. And it is everything that you ever wanted to know about spraying using air. There are a lot of basics in here, lots of illustration, and it's free in English and French, not Spanish. But if anyone has any way for me to translate it, I'm interested. You can find it on Sprayers 101, which is a website that I operate with a colleague. We have more than 300 articles, calculators, comic books, videos. It's a little goofy sometimes, but it's lots of fun. In fact, I'm writing an article right now about nozzle spacing and boom height, just what we spoke about a moment ago. And I encourage everyone to go check it out. So that's it for me. I'm happy to take any questions.
Great. Thank you for that excellent presentation, Jason. And I think that there's footage of anyone who's ever used a backpack sprayer doing that sort of wiggle twerk dance move. And it's embarrassing. I'm going to go ahead and launch a poll. So Jason, again, please refrain from touching the computer for just a second. But if you do have questions for either Jason or Anna, go ahead and please put those in the chat now while I launch this poll, okay? There is a question already in the chat, a question from Larry. Jason, for the calculation of 30 feet on that air assist mist blower, is that a 30-foot pass-through of multiple rows of crop, or just how far you can be from a single target?
Hi, Larry. Great question. And I think you and I both know the answer to that. That's a marketing number. We did a lot of testing on air cannon systems and backpacks. The further away it gets, the less control you have over the spray. A gust of wind will steal it. You can't rely on it. So 30 feet would be standing in a parking lot on a calm day with nothing in the way. Every time you hit a crop, it deflects the spray, it interferes with it, and changes it completely. I would never use a backpack mist blower to spray more than one row of a crop. I'm like a high bush blueberry or a tree. You may be able to roll it over a couple of rows of planted canopies in a row crop, but not too many. And the further you go, the harder it is to predict. That's the same with any directed air assist sprayer. Use your water sensitive paper and see how big a bite you can take.
Great. And one of our participants had to hop off, but did send me a question before leaving. And that was, do you have any experience with or opinion on the newer battery powered like solo backpack sprayers that supposedly give you more consistent pressure as opposed to the more expensive CO2 powered models?
I don't have personal experience, but I'm dying to get one. These became far more available with COVID because people were using them to spray disinfectants. The same with electrostatic, which, spoiler, I don't like those. But these battery packed systems have a lot of promise. And with them, you don't have to worry about refilling gas canisters. Although I've never had a problem getting refills. Just go to someone that does welding or your nearest brewery, and they're happy to fill you up, gas and beer.
I haven't tried the brewery route though. Maybe I'll do that now on your recommendation. But for folks who are in the Hudson Valley, at least, we use CO2 powered backpack sprayers for all of our efficacy trials that we conduct, and so we have all the spots kind of mapped out where you can get small canisters of CO2 as well. Are there any other questions for either Anna or Jason before we wrap up? It looks like Nicholas had a quick question, which you're probably, I think I know what you're going to say, but do you have any recommendations for a small non-backpack sprayer to use? And this would be in a smaller scale, organic, diversified operation growing blueberries, but also some vegetables.
I'm biased. I've seen too many non-air assist systems in high bush blueberry. I'm assuming you mean high bush and not sessile row blueberry. And without air, you are not getting in there. They try this in British Columbia with conventional operations using field sprayers that broadcast from above. And it's just what you think. 90% is on the surface, very little gets in. And depending on the direction you aim from, that's the side that gets drowning coverage while the rest gets very little. So a sprayer that can do all things for all people, not really. We would have to talk more about what your operation is. And I do recommend you get a copy of the Air Blast 101 book. There's a section in there called Spraying Strategies. And it asks a number of questions to help you figure out what features are important to you and give you some direction if you're picking a sprayer. But if you want to reach out to me afterwards, you can reach me at jason@sprayers101.com and I'll see if I can help.
Great, thank you for that. I have a question as well, but it looks like Guillermina also just shared one quickly. And so that question is, cuando sprayas con viento, tiene que ser con mucho viento o muy poco? So if you're using, I think you're referring to—
When you spray with wind, do you spray a lot or do you spray a little? Entonces, can I speak?
I think I got the question.
Okay,
When you
yeah.
spray with wind, too much or too little? Well, almost always people use too much. It's human nature that bigger must be better, but not in this case. You only need enough air to carry the spray to the canopy and then penetrate into the canopy. When I work with growers, it seems 90% of my time is trying to find ways to use less air. It's not always the case, but quite often it is. And this is because a lot of our crops are densifying. They're getting smaller, they're planted on smaller row spacing. And the sprayers, the fleet of old air blast sprayers, for example, that we use, were designed to spray way up for old apple trees and bigger targets. So I try to teach moderation. There are all kinds of ways for you to do it simply, to figure out how to control your air, your travel speed, and how to know if that's enough. And it's as cheap as buying a few pieces of ribbon. The whole protocol is on Sprayers 101 and in the book. And again, I recommend you give it a read.
Great. Well, I don't see any other questions in the chat, and seeing that it is 1:12, I think we should probably wrap it up. So Ana Maria and Jason, I want to thank you both so much for making the time and sharing your expertise with us today. We will, like I said, be posting the recordings of these webinars when they're available. So if anyone has any additional questions, I'm assuming they can reach out to you at the contact information that you provided, but also feel free to reach out to me or any of the session organizers. The next workshop will be 2 weeks from today at the same time, and will be focused on applying pesticides safely and legally from the perspective of the New York State Department of Environmental Conservation, who regulates pesticide applications in the state of New York. So thank you again so much.